define a new vector from scratch if I want to. I can drag in a new vector parameter, open a menu, and choose set one vector, which will allow me to pick a vector on the screen, for example, over here. And if I share this vector, we now have that translation. So if the point moves, the moved point also moves with the same translation. But we don't want a fixed vector. We want a vector that points straight up but has a variable length. I can make one of these vectors. From the vector tab, there is a vector from x, y, z component, which allows me to set both the x, the y, and the z components of a vector. And by default, they're all 0. But I can overwrite the z value. And now this vector is, as you can see in the tooltip, 0, 0, 10. And as I change the slider to, say, almost 5, the vector will be 0, 0, 5, 0, 9. So if I share these two together, I can finally control my elevated point with this slider. Okay, that's about 4 steps there. Import the points, make a line, get the midpoint, and move the midpoint. And our last step here was to actually make an arc from the line start point to the raised point to the line end point. So I can once again search for arc and see what comes up here. And the first 3 hits are all components that create arcs. So the first one creates an arc from a plane and a radius and an angle domain. And the second one creates an arc from 3 points. And this one creates an arc from a start point and end point in a direction. Now I have 3 points, so I need to use this component over here. And it's actually a bit bigger than most ones we've used so far. It has 3 inputs: the start point of the arc, the point on the arc interior, and the end point, A, B, and C. And the outputs are the arc curve, the plane of the arc, and the arc radius. So we have all this information available once we make this one arc. Now the start point is the same as the line start point. So I can share this one point parameter here with both the line and the arc component. And I can do the same with the line endpoint. It feeds both the line component and the arc component. The arc interior point is our elevated point here. So it becomes point B, and now you see that there is an actual arc. Goes straight up, which is controlled both by this slider here and by these points in Rhino. So if I change this point in Rhino itself, it updates the whole definition. Are there any questions so far, Mary, about this?
Hi, David. Yeah, we do have some questions that are coming in. The first is a request to stay over the icons a little bit longer to allow it to update for people. So anyway, maybe we can try to do that. Javier asks, why do the points look black and different from the ones in Rhino?
The points, well, they shouldn't look black. They should look either red or green, depending on the selected state of the object. So if I select the arc goes green. If I select this point, that point should go green. And they look different because I thought it was useful to know if a point is a Rhino point or a Grasshopper point. So Rhino draws points as either dots or squares, and Grasshopper draws them as a cross. Or maybe you were asking why my points in Rhino look different, which is just a setting in the display options. I prefer to have thick black dots instead of the white and black squares.
Okay, and then another 2 questions were pretty basic. Where can I get the latest version of Rhino, and how much does it cost?
Rhino or Grasshopper?
I'm sorry, Grasshopper. Yeah, of course.
The latest version is available on via our forum. So you go to www.grasshopper3d.com, and there will be a download link there in the download section and also on the discussion forum. I think the last public release is 0.8003, which is I've actually moved further here, but it's very similar to the one I'm showing, and it's free so far. It's still in beta, so you can download it and use it, and there's no time limit. So if you get it today, you can use it forever.
Okay, great. And another question, what was the tool that defined the z-axis?
Z-axis, good. All the points in Grasshopper and all the, in fact, all the geometry is defined in world space. So there's no concept of a z-plane in a Grasshopper. So when I make a vector from 3 numbers, x, y, and z, x is always parallel to the world x-plane, and z is always parallel to the world z-plane. So by leaving x and y 0, and only setting the z vector, I ensure that this vector is going straight up all the time. Now, if I don't do that, if I also change the x and y vectors, for example, if I copy the slider and also override the x vector, you can now see that this arc becomes slanted as the point is moved in both vertical and horizontal directions. In fact, this is a bit of an overkill here. I didn't have to use this component. I could have used the unit z-axis component. If you go to the vector tab, vector panel, there is a unit x, unit y, and unit z component. And unit z creates a vector that is going straight up. You can just set the length of that vector. So this is in fact the same thing as before, but now we can only control the length of this vector as it goes straight up. It can move in some other direction here. So you can use this if you want to have a fixed direction, and you can use this if you want to control all 3 directions of the vector. Of course, if I put this thing in a side view, for example, in this view, then the word up means something else in this direction, in this C-plane. In the C-plane, we have x in this direction and y going up, but the world axes are always the same, no matter where you are. So get about C-planes and always think in world coordinates.
Perfect. And the next question, does Grasshopper adopt unit settings from Rhino? And then we're done with questions.
Yes, in fact, units are, well, they don't really exist as such. It's just numbers. Units only come into play when you display lengths and distances and areas. That's when we have to decide whether 14.6 actually means 14.6 meters or inches or centimeters. So it just uses numbers, and it just uses this distance of 1. And in fact, I don't think there's units at all in Grasshopper. So if you want to format stuff, you have to invent your own unit systems. But I'd like to take this definition and make it a bit more flexible. What we've done so far is generate one line, one midpoint, one elevated point, and one arc based on these 2 inputs. But what if I didn't have 2 inputs? What if I had a lot of inputs here? So instead of picking 2 points out of Rhino, I'm going to actually draw 2 curves by hand, divide those 2 curves, and then use those points on those 2 curves to seed this structure. So I'm going to change the inputs here at the very start of this definition, and divide the curves and override those point coordinates. I can search for the word divide, and it will have a bunch of hits here. It will find stuff like divide domain, divide by distance, division, A over B, and even things that rhyme with divide, like inside. This is a very flexible search mechanism here. I want divide curve, which takes a curve input, so a curve to divide on the C input here. It takes a number of divisions, and actually there's already a default of 10 in this input. And it'll take a Boolean value, true or false, that says that whether you want extra points on curve kinks. And this is an option that doesn't exist in the Rhino divide command. You can't have extra points at kinks. But since our curves don't have kinks, they're all smooth at this point, this option is ignored at the time being. So I can make a new curve parameter, drag it from the toolbar, from the toolbar here, and drag it onto the canvas. You can open it up with a menu and choose Set One Curve. Just like I did before, with points, I can select one curve, and now the curve goes red. So it's now been referenced by this parameter here. So I can do it again, go to the toolbar, create a new parameter, open the menu, and choose Set One Curve. Pick the other curve. I can share the curve, so it actually generates those 10 segments, which is a default number here. So I can copy this component and also operate on the other curve. This component here outputs the points, which you can see on the screen here, those green points. It also outputs the tangent vectors at those locations. We won't be using them today, but they are there if you want them. And it also tells you the parameter on the curve, where those points are. And since I'm guessing most of you don't know what curve parameters are, we'll just skip over this for the time being. So we have these new points here, and I want to override the old reference points, which are stored inside this parameter. And I can just easily rewire those inputs. And this will override local data with external data, and now you see that these arcs are actually populated along these division points. So instead of just making one arc, I now use the same file to generate 11 arcs. Or maybe not 11, but even more. Let's say that we can go to 50 in this divisions. So I need to set both divisions to 50. And I see it actually generates 50 arcs between these two curves. And all the arcs have the exact same height, because that's still controlled by the elevation slider over here. So if I change the slider, all those arcs move up and down. Okay. So that's the first example. Before I move on, just any more questions still?
Yes, David, a few more came in. There's two that are very similar. Can you import curves from Rhino or from other CAD packages and parameterize them with Grasshopper?
You cannot import from other CAD packages. It has to be a curve that exists inside Rhino document. But of course, since Rhino allows you to import file formats, you can import DXF or DWG or whatever format and reference that geometry. It is technically possible to actually parse files inside Grasshopper. So if you have a vermal file or a XYZ point file, you can load the file directly without going through Rhino. But if we have time at the end, I'll show you how to do that separately. And reparameterize, I'm not quite sure what that means. I mean, there's an option to reparameterize curves, but I'm not sure if that's what you meant.
Okay, how about another one then? Can the slider be set to a negative value?
Yes, absolutely.
Okay.
If I open it up by double-clicking, I can change this domain from between any two numbers which are possible. So -10 to +10, for example. And now I can go negative, and the arcs will go at the bottom here. Since I drag it below the 0 point, I'm still waiting for the update. There we are. It'll create arcs at the bottom. And if you pick a value of exactly 0, it of course will fail, because then you have 3 points which are actually collinear. If I force the value to be 0 exactly, we get 3 points that are actually in the same line, and we can make an arc between 3 linear points. Now it will have made these, so instead of arcs, it'll actually make line segments this time. But it will also tell you that there's a warning here. And the warnings are for all the inputs that collinear point result in a line segment instead of an arc. So this is a dangerous thing to do. But any other value should result in a valid positive or negative arc. Okay, so this is all stuff that you could do by hand in Rhino, just drawing arcs and lines and points. So the next example, I will show you something which is not possible to do in Rhino, or at least very, very difficult.